Hello students, myself Muthura JNP, working as assistant professor in the Department of Mechanical Engineering at Vidyavardhaka College of Engineering, Mysuru 2. I will explain thermal efficiency of diesel cycle derivation now. First and foremost, for any derivation, you want to note on the PV diagram for this diesel cycle. PV diagram you note on PV, pressure volume, 1 to 2 is adiabatic compression, 2 to 3 is constant pressure heat addition process. What will happen in this particular point? The piston compress the air up to particular point 2. When it is compressed up to particular point 2, then the air will be compressed and the temperature will be increases for certain amount of value. Then heat will be added at constant pressure. At what in this same time what will happens, the piston will move from the top dead center to the bottom dead center slightly, then its volume is increases but pressure is maintaining constant. The pressure is maintaining constant and then heat will be added to the system. And then 3 to 4 is adiabatic expansion process. This is what we so called as the power stroke. And 4 to 1 is constant volume heat rejection process. Constant volume heat rejection process. In the engine, here only air will be compressed up to this particular point, and then fuel will be injected at the end of the compression process. When fuel is injected at the end of the compression process, from the top dead center to the bottom dead center, slightly the volume is increases and then at the constant pressure. Therefore, the heat will be added at the constant pressure process. See, heat will be added like this, and then after the heat added, the fuel is injected, power stroke will be takes place, piston tends to move from the top dead center to the bottom dead center, and then working stroke will be like this. Therefore, this is the schematic sketch of your thermal efficiency. It will absorb the heat from the high temperature reservoir at the temperature T1, let me say temperature T1, high temperature, and then it will be converted into some amount of the work. Some amount of the heat will be, the converted work will be Qs minus Qr. The diesel efficiency is output by input. Therefore, your diesel efficiency is Qs minus Qr divided by Qs. You can call this equation number 1. Now, you can go for the diesel thermal efficiency analysis. From the PV diagram, it shows that Qs is equal to Cp into T3 minus T2. Why Cp? Because heat is adding at the constant pressure process, and then heat rejected at constant volume process T4 minus T1 Cv. Therefore, your equation will be like this: Cv into T4 minus T1 divided by Cp minus Cp of T3 minus T2. Therefore, efficiency, you know that Cp by Cv is gamma, but here it is Cv by Cp, therefore 1 upon gamma. Therefore, this is the equation. Here in this equation, you want to put all the values in terms of the T1. Definitely you can convert the everything T3, the maximum temperature, T thermal efficiency. See, you know process 1 to 2. T1 V1 gamma minus 1 is equal to this one, you know very well. T2 is equal to T1 RC to the power of gamma minus 1. Process 2 to 3, it is what? Constant pressure heat addition process. P2 is equal to P3. So you want the value of T3. You already have the T2 is equal to T1 RC to the power of gamma minus 1. You want the value what? T2, and then you can put T2 here, and then it will be converted into T1 RC to the power of gamma minus 1. P2 is equal to P3, T3 is equal to T2, P2, and then this will be converted into T3 is equal to T2 in V3 by V2, and rho is equal to V3 by V2. It is very important concept, that is cutoff ratio, where fuel will be added from particular volume to the another volume. That ratio if you take, that will be so called as the cutoff ratio. This is very important concept while doing the problem. The cutoff ratio is equal to V3 by V2. Therefore, T3 is equal to T2 into rho, T1 in terms of T1. Therefore, put T2 value or T1 rho into RC to the power of gamma minus 1. You know the process 3 to 4. 3 to 4 is adiabatic expansion process. It is T3 V3 gamma minus 1 is equal to T4 V4 gamma minus 1. Therefore, what do you want the value? You want value of T4. Then that's why you rearrange it and then take the T4 is equal to V3 by V4 whole to the power of gamma minus 1. Then just divide and multiply by V2. Therefore, V3 by V2, V4 is equal to V1. V3 by V2, V2 is, V3 by V2, very well, this is rho. V3 by V2 is rho. V2 by V1 is 1 by RC. RC is equal to 1 by V1 by V2. Therefore, T3 is equal to V3 by V2, then rho by RC to the power of gamma minus 1. Already you put all the values here, you will get the values what? The diesel efficiency will be like this. Therefore, your efficiency will be, this will be your efficiency, that is 1 divided by gamma into RC to the power of gamma minus 1 of rho to the power of gamma minus 1 divided by rho minus 1. Thank you.